Today I'm going to show you how to make a 9-character, 4-digit keypad lock for your door to your base in Minecraft. The combination is center, up left, up middle, bottom middle. But you can have whatever combination you want. Then you press enter, and in a few seconds the doors open. This button here will close the doors. And it will also open the doors. The enter button will close the doors if they're open without entering the correct keys, but will only open it if the correct keys are inputted. This is the circuit. It is fairly long and looks fairly complicated, but it's not. There are 4 main parts to it or so. This part here figures out what buttons have been pushed on the keypad. These buttons here, or this area here, keeps track. This one determines whether it's the right button pushed, and this area back here keeps track of how many buttons have been pushed. Then this provides a reset loop that will reset the code if the wrong buttons are pressed or if the enter button is pressed. And then, this is actually the, no, that is the reset, yeah. Oh, I see. And then there's also an underground reset loop which can set all the code buttons and hit the reset button. So to make this, other than the button breakout, I used 2 circuits, really, or two creations. One of which I figured out myself, and one of which I borrowed. The one I borrowed is a latch. It is just 2 pieces of protruding material with a torch on the side of each, and then when you add power over here, it latches. And add power over here, and it latches. Those can be found here. Then it has a dioded loop to the next one. So if the first gate is tripped, then all the gates will trip to being locked again. That was the first one. The second one I made can be found over here. I had to figure out a way to switch which way an input came in or out. So this one selects which way it goes. This comes from the previous latch gates. And this comes from the button. Determines whether the gate is on or not. If it's not on, no power will flow. Here's a compressed version of it with edging, and I'll show you how to make one of those in just a second here. But this functions exactly the same. Power in on that block, or sorry, switch in on that block, power in on this block. To build one, you make a arrow key shaped rise of rocks, put a line of redstone on top of it, put a torch on the up arrow, then put a torch on the side of both side arrows, Have a piece of redstone lead up to those, and then have one block that is not part of the arrow keys there, with a torch on only one side, and a line of redstone on top, and your output redstone. Now you put a block there and there. Now, we're going to assume that we're getting current in the other side. As you see, right now we're not getting any current, and nothing happens when I toggle that. But by putting input in, now a current can flip which one is on. Those are located here. The first one is directly controlled by the button. Right here, it throws the latch to open, and then since it's in the open position, it tells the redirector to stop redirecting down the reset loop, which is buried underground. It's a little bit difficult to access. Let me see if I can't get in. And the reset loop is an always false current that will flow backwards down the entire string, so it will reset if a single piece is pushed true. So it will stop redirecting power down there and start redirecting power to this second latch. Then the input is connected to your second button, and that repeats until you get to the enter button. And now the enter button is special because in addition to being the last button in the sequence, it has to go to the door open, but get also ready to reset the circuit. So I've done that like this. I have a normally off wire going over to an inverter and into a rising edge switch into an inverter into my reset switch. That will close the door once power has been turned off. Then, let's see here, how does it determine? This line here will only turn stuff off after the enter button is pressed a second time. Then there's the inner button, which goes down this shaft, and it goes straight to this, buried in there. That will power the gate and this, and as well over to these, which are redstone torches under torches hooked to repeaters, so one of them triggers at a time, under the inputs to the circuit. So it will trigger all of these in order to open your circuit. And that's more or less how it works. The only other thing is it doesn't matter what speed your code is put in at. You can put it in really fast, and don't let the buttons pop out before the next button is pushed, and it will work just as well as if you put in... I have to wait for it to close and the circuit to reset. Okay, it's reset. Just as well as if you put in one button, went for a stroll, put in another button, went for a stroll, put in the first button, then that button, and then hit enter. The only downside is this lock can only use a number once. Why isn't it opening? That's interesting. It doesn't want to open when I enter it really slowly. But no one is going to try to enter their password extremely slowly, so that shouldn't be a concern. But you can only use each number once in current configuration. You can use any number of numbers, though, by just adding another one of these to the sequence. And there should be a way to make it so a button can be pressed multiple times, but I'm not sure how it is yet. The way you access the number pad is easily shown over here. The bottom three buttons, or the middle on the bottom, goes down to a lower row, and it is the only button on the lower row. The sides on the bottom go out the side. The tops corners on the side will go out the sides, but on an upper layer, the top button will go straight up through a block into a redstone piece, and the middle button will go out through a repeater to isolate it from the side middles, which will each go out through their own string. Then you can take this one and keep going, and this one and drive it over that one, and you can sort everything out. That's what this mess of spaghetti is doing. So that is how the code lock works.